Good morning.
Good afternoon.
Good afternoon.
Good afternoon, good morning.
Technically, it's evening, I guess. So, yeah, good evening.
Hello.
Hello. Just give it one more minute for folks to trickle in here. All right, it's 3 after. Let's get started. Welcome everyone to the Tuesday, April 5th, 2022 SIG Multicluster meeting. Laura, it looks like you are our agenda today. So
I am.
you have the con.
Great. Okay, I am going to attempt to share my entire desktop. Hopefully that is okay there. Okay. All right, so I wanted to talk today about the About API. And I have a little demo to show and also some slides I want to share. In particular, there are some discussion points I kind of want to ask about the group too later. So let me slide over here to these slides, which are linked first, I think. Here we go. Okay, so let me re-establish what the About API is, formerly known as cluster claim, cluster ID, and you may have also heard the word cluster property. So all of these are referring to fundamentally the same thing. So just triggering anybody's memories there. And overall, this is from KEP 2149, cluster ID for cluster set identification. And it is now implemented per that KEP in this repo. I'm going to show a demo of this later, but that's part of the big reveal of today. And just to remind everybody, this is a cluster scoped CRD that basically maps a name to a value. And there are specific usages of this that are needed for MCS, which is why we worked on this in SIG Multicluster. In particular, this one called id.kates.io, here's two potential examples of it. This is a cluster property in the About API that identifies a cluster by its name. So this is a way that like a cluster can ask itself what its name is. There's a lot of sort of background in the KEP too about like what this property should look like and what behavior it should exhibit to be conformant with this KEP, and in particular for its usages in MCS, but I won't go into too many details about that. This KEP also specifies that there should be a well-known property called clusterset.kates.io that identifies what cluster set this cluster belongs to. So again, the cluster is self-aware of what cluster set it has membership in. Again, the KEP has a bunch of details about exactly how that resource should behave. But as mentioned, and these last bullet points are just like, there's a bunch of reasons that we need this for MCF, and this is how we have implemented it. So that's a little bit of background. And one other background point I want to make is that even though there are, going back a slide really quick, these specific named properties, id.k8s.io, which has to have like certain behaviors, and clusterset.k8s.io that has to have certain behaviors that is specified in this KEP. The KEP also opens up the floor for people to use the CRD to store any other resources with any other name, as long as they follow some general guidelines, which is basically that they can't conflict with the well-known ones, have to use a suffix, and can't use the reserved k8s.io or Kubernetes.io suffixes. So just want to bring up, in case it's an interesting point of discussion here, or just like as knowledge, this is something that could become, arbitrary properties that any specific implementation of anything decides to use, and they should suffix it by something that is informative as to what their implementation is, so that it can not get conflicted by anybody else. One that has been discussed in this forum is a cluster property that identifies a cluster's primary network for multi-network purposes. This is still in conversation elsewhere in TBD, but just I wanted to bring it up here as like, this is an example usage of the About API for something that isn't in the original KEP, but may need to or want to be like escalated as like a official well-known property, or just like as info that this is kind of a place that if you needed random metadata about a cluster, this is potentially a place to put it. And one other thing too to mention is that this value field is just a string with a length limit and no other validation on it. We will talk a little bit about that length limit validation itself too, but it can be of any form. Again, the well-known properties have some rules, and individual implementations can make up whatever rules they want about what their value should look like. But as a CRD, it doesn't establish any specifics. Okay, quick demo. Major shout out to Ishmeet, who I believe is in the call. I am just a messenger. She did all the work for actually implementing this. So super grateful to that. And I'll just give you a quick look over here. So as mentioned, this is accessible. You can grab it from the Kubernetes SIG's About API repo here. So I just pulled it up in my VS Code over here. And I have, this is so small, sorry. There we go. Hopefully that's visible enough. So I'm in my, I pulled this repo here, and I also have a kind cluster running locally that right now is super clean, doesn't have any CRDs installed. So this CRD is constructed with Kube Builder. So if you have experience with Kube Builder, it has all the normal like make commands from all other Kube Builders CRDs. And so we can run make install. And as long as you have your customize and your controller gen binaries installed properly, then we can see that now this CRD exists. So this is the About API CRD. And again, back here, you can look at the source code on GitHub as well, but this is the actual definition that is being applied there. And then one other thing that I want to just show concretely is I first have to remember what directory it's in. It's in config samples. Yes, okay. So I have in the repo already, committed in the repo, there is this example one custom resource. So we can apply this in here. This looks like, sorry, I can't talk and type at the same time, it seems today. Property. So, there we go, this one. So we can see that it's created this cluster property. This happens to be one that is using this name id.case.io. So the whole idea here is that anytime to like this API, you could request, hey, what is my cluster property with this well-known name? And you can get this, let's get this out here. You can get this resource back, which has this value, which is whatever the name is. So that's like the whole purpose of this API, and especially in terms of this cluster being aware of its own name. Okay, so I think that is what I wanted to show there. I'm going to go back to my slides here. Oops, slideshow. Okay, so super happy that that now exists. You can play with it, you can mess with it, and also importantly, it's now the KEP is implementable, and this is basically the alpha API for it for the purposes of the MCS API progressing itself to beta and eventually GA, which is dependent on this. Okay, so for this KEP itself, for the about APIs KEP, it has its own graduation criteria separate from the MCS API's graduation criteria because they're two different KEPs. So I want to dig into a couple of these, and also I will save some time at the end to just revisit these graduation criteria generally if we need to. But there's 3 alpha to beta graduation criteria. One is related to what if this ID must be strictly a valid DNS label or is allowed to be a subdomain. I don't think we totally finalized that, so I kind of want to come back to this at some point. We had ancient conversations about that like way last year, and it also intersected a little bit with SIG cluster lifecycle and the cluster API. So I kind of want to revisit those notes before I say anything too unintelligent about that. So I'm going to table that one unless someone feels strongly about that for later. To CRD or not to CRD, just as history, there's a lot of conversation about whether to implement this as a CRD or in KK, and we talked to like SIG architecture about this and discussed a lot at length here. In the end, we decided to go for CRD, which is how it's implemented now. So I consider this tabled, but happy to talk about that more later as well. And then the two, or sorry, not two, but this last one here, I do have a separate slide on, which came up during API review for this alpha implementation related to that length limit. So we have a length limit on the value for any cluster property, and our means to enforce it are kind of dependent on the CRD implementation, and there's some decisions that we can make about how we want that to work. And then one other thing kind of going on in the background is later on, when we want to move cluster ID to GA or cluster property to GA, we need at least one headless implementation using cluster ID for MCS DNS. This is available to be worked on if anybody is interested in a coding project. There is already a core DNS plugin for multi-cluster DNS that isn't leveraging cluster property yet because it didn't exist, and therefore it doesn't create pod DNS records. So we would like to integrate that, and then that is also a GA blocker specifically for this KEP. So just heads up that that is an open project. And I'm going to jump into the nitty gritty about this length validation so that I can get some opinions from here. So through the course of the API review, and there's many comments and lots of empirical data and gists that were discussed as well. But the value for cluster properties, we originally wanted to limit to 128,000 bytes. But the Open API validation that the CRD depends on is only capable of determining a max length based on Unicode code points. This is not the same as bytes because it depends on the encoding of the in the first place. And the note down here sort of mentions that how this turns into actually byte lengths varies, but in the worst case, using UTF-32, which is the least space efficient allowable encoding per OpenAPI v3 specification, would be 512 kilobytes, because that's 128K times 4. So this is how it's written right now, and this is how the validation on the alpha version works. It's based on Unicode code points. But there is another option called cell validation, or maybe we call it CEL. I don't know, but I think cell sounds cooler. And I want to compare and contrast these, including their potential cons. So right now, we're using this OpenAPI v3 structural schema. This is kind of like seems really lingo-y word, but basically is that there's some validation fields that are based on OpenAPI v3 that you can set, but they're restricted by the Kubernetes implementation. So Kubernetes only allows like a certain subset of the total possible OpenAPI v3 validation fields. And there is a max length field, which is supported by Kubernetes. But for string types, as mentioned, it only works on Unicode code points. And again, if you go back to the history of this KEP and look at all the comments, there's a lot of like empirical testing of that to confirm that that's the case. One nice thing about OpenAPI v3 structural schemas is that max length and all the other things in structural schemas are available since CRD went v1, which was Kubernetes 1.16. So it's just in your vanilla Kubernetes version since 1.16. And I do want to highlight that there is something called bytes type in this OpenAPI v3 specification, including in the Kubernetes restricted subset. But what it actually means is some base 64 encoded data. So like it has to be ASCII. If, for example, we were to use the string type, we would be expecting people to write their like arbitrary values in base 64, which is super unusable, because then if you do like a kubectl get cluster property id.k8s.io and it's like this, you don't really get to use it directly. You have to decode it. So that's what's going on with OpenAPI v3. Over on the cell validation side, this is a new type of validation for CRDs that has a way more expressive syntax. It's particularly useful if you need to make comparisons cross-field, like the OpenAPI v3 structural schema super can't like compare two fields to each other, but cell validation can. I don't think we super care about that, but what we do care about is that there's a bunch of built-in macros. For example, it has a casting function that can take some string, aka Unicode code points, turn it into bytes, and then furthermore, calculate its size. By definition in the cell validation spec, it assumes that we are encoding it into UTF-8. So this is the type of cell expression that we could write that gets a little bit closer to our original thought process of trying to limit by bytes. But the probably biggest downside is that this feature is currently in alpha as of 123. So it just straight up doesn't work before 123. And then for people to therefore use like this validation and install the CRD in 123, they would need to turn on the feature flag. They would need to make sure their feature flag is turned on for this feature. And then I don't exactly know if it's planned to go beta in 124 or not. In any case, I think beta is not feature flags on by default anymore. So there's just some like window of time that is 1 to n cycles for before this becomes a default feature. And just historically, we've been a little worried about making the CRD harder to install because that then makes basically MCS have less supportability for older versions of Kubernetes. So I want to pause here and take opinions about this and also answer any questions if I didn't explain anything clearly.
Yeah, I raised a hand on this. I think.
Oh, sorry, didn't see.
No, this is when I wanted to talk. So thank you. as long as it's a string field, validation based on the encoding length seems like a pretty poor UX in my mind. I kind of like the current validation because what you see is what you get. It's number of characters. That's something that's really easy to reason about. When it's based on bytes and the encoding changes the max length, and then you have to reason about it, that just seems a little bit rough.
Yeah, so definitely like the song Unicode Consortium has been singing this whole time is definitely the same. Unicode code points are easier to reason about and are interoperable. I think where the bottleneck is for people is like if etcd has to write it down in bytes and it has some limit. That limit is way higher than I think we can get to. I have some notes that I kind of forget the details about that. And it's kind of hard, at least for me right now, to interpret how much a larger value impacts that, since I don't know exactly how the Kubernetes API writes down in etcd like individual resources, like are they split up into different key values, or is it like one big blob, that type of thing. So but that I think is fundamentally where like the problem would manifest in terms of like causing actual, like where the limit could cause an actual problem if it's
right,
wrong. And then that fundamentally is tied to bytes, and that's the only reason why I think we're like even playing this game.
And that makes sense. I just think that given where we're at, what I think we should do is look at that limit. If it's significantly higher than the 512 kilobytes that this would be, then I think that we don't have much of an issue. But maybe the right way to look at this is just figure out what the limit is, figure out what overhead we need with the CR, and then divide by 4 and call that the the max Unicode length. But I think expressing the constraint in Unicode is probably the way to go, and we should just work back from the limit. If I remember correctly, the 128 was arbitrary anyway.
It was.
So if it needs to be another arbitrary number because that's too big, it's probably fine. But I believe that we're nowhere close to the.
Yeah, I have a feeling we can go up. I do think there's some like very detailed, like how are these CRs written to etcd that could inform me better about like the overhead, like you say. And so I think I just need to find somebody who can help me with that. But yeah, I feel like we're super way off. So it's probably okay.
Cool.
And
yeah. Go ahead.
Yeah, just I guess this whole conversation is also just trending like cell validation, therefore, is one, a downside because it gives us less version compatibility, but then not even valuable if we are now like basing it on the assumption that making the like communicating the limit in code points is the better way anyways.
Yeah.
Okay, yeah. Cool. Anybody else? Or Jeremy, did you have another comment?
No, that's it.
Okay. Anybody else feeling strong? Okay, cool. I'm gonna move right along to just talking about next steps for the About API. And oops, I didn't mean to do that.
Dzień dobry, słucham.
There we go. Turn on the laser pointer is what I was trying to do. So there is a controller binary, like controller code in the repo, the About API repo, but right now it's mostly boilerplate. And right now we're working on, given some startup label, to automatically insert an id.case.io cluster property based on the current cluster's cube system namespace UUID. So people will probably recall that this was discussed for the KEP. Somebody is not on mute. That's okay. Thank you. Sorry, couldn't find my buttons. Okay, yeah. So in the KEP, and we previously discussed in this forum that like a nice default for id.case.io could be the UUID for the Cube system namespace. And this has been talked about in other forums too, like before SIG-MC. And we want to kind of make this an optional thing to occur using this controller implementation. We have some other ideas of things that could be cool to put in this API that might be useful for folks. Here's a couple ideas. This also might be in particular something that would be good to talk to SIG Cluster Lifecycle about. They have a ton of their own things that they need to keep track of that they've like put into different like annotations all over the place. And they might like to consolidate some of them or at least advise us on what some of these interesting properties are. But I would like to open the floor to just trying to get a better sense on what the overarching direction for the About API controller implementation in the Kubernetes SIGs repo should be. What do we have any sense of like what actually belongs in this like open source controller implementation as opposed to like, should like people be separately implementing like whatever properties? If we do decide that one of these or all of these things should be well-known properties, does that give them any reason to be like, handled somehow in the upstream controller implementation? And then also, how do we want to make a process to onboard new well-known properties? Is it just going to go through new KEPs or stuff like that? So there's kind of like a swirly level of questions I have of just about like, at this point, like the About API is like sufficient for the immediate use cases we have for the MCS API. It doesn't need anything extra added to it. But there are these other things we could be working on, and do we want to, and like, do we have any goalposts of like kind of where the line is my question. So I'll open the floor for that.
I think it's probably worth shopping around with other SIGs. Like if there's any other properties that we're missing. This list seems really good, but it's also actually all implementation dependent. Like every platform has their own definition of these things.
And maybe Cluster API has some specific things going on per provider, but I don't know if this, that's the only potential place I feel where that could be standardized.
Or, and then the question is, if it is standardized, because I agree with that, should it be cluster property that standardizes it or cluster API?
Right.
Like maybe cluster API becomes depends on cluster property and just sets these.
Yeah, which was a conversation that we had with SIG Cluster Lifecycle like a long time ago when we were first proposing this. But there's no like, we haven't officially been like, this is the dependency for you or anything, right. So, and they may choose not to.
And then on the other hand, like even service cider, which I believe every Kubernetes platform has today, from talking with SIG network folks, even that might not be something we can always count on going forward. I mean, there's nothing that actually requires a service cider in Kubernetes. That's why there's no property right now. Like there's nothing stopping you from just assigning VIPs at random from some from your own IPAM service. So yeah, it's tough. Speaking from a GKE standpoint, I know some of these are certainly useful, but I don't know that we can make the statement that they should be standard across platforms. Like, if I'm looking at a vSphere deployment, region means something very different than it would on AWS or GCP. So that's my 2 cents.
Yeah. Okay.
Maybe start simple.
Yeah. Okay, so I think what I did here was, and like I already had the sense that I should probably go talk to SIG Cluster Lifecycle just to give them the update of like, hey, remember we talked a long time about cluster property? We made this thing. Is there some type of things, either implementation dependent or not, that you might want to see in here, and how should we work together or not to do that. So I think there's that. And then I get the overarching, I'm hearing sort of like a keep it simple, especially our like upstream implementation for now. At least the ideas that we have currently are to have too many exceptions, or are not necessarily as like clear cut than we would like compared to kube system namespace UUID. And then, yeah, just separately, I think like this question of like what becomes a well-known property and how to onboard them, I would like to at least, I mean, I think fundamentally in the very short term, we can say like go through us, and then we can kind of work out the process as time goes on, especially how much we need to think about that varies of like how much like this is useful to other folks, like say cluster lifecycle. But I do think that there probably will want to be some sort of like way to get like a case.io or kubernetes.io that definitely has to go through API review. But how people actually do that, I don't think I have a good way to advise besides like, come talk to me and I'll figure it out with you. So.
Let's see, Ishmeet has a hand.
Oh yes, go ahead.
Yeah, hi Laura. I think I kind of agree with Jeremy was saying, but I do see a value of having, you know, CIDR ranges as cluster property, like service, pod, and node CIDR. That might be useful for lifecycle as well, or, you know, just pulling data from each cluster. So that the multi-cluster you know, don't conflict on CIDR sometimes. Like, for example, you're building clusters on-prem, and you definitely want to see that you're not using a particular CIDR for another cluster. So that might be useful over there.
A big plus one to them being properties. It's just the question, I think, of whether it should be standard properties or like,
or yeah,
or per vendor, like, you know, a .vsphere or .gke instead of kates.io.
Right.
I think service, pod, and node are generic enough CIDRs that they can be generic. But cluster, project, VPC, and region could be vendor dependent. You know, how you annotate a region and project, it might be different between GCP and AWS and Azure, so on and so forth. But CIDRs are pretty generic in every implementation of Kubernetes. So
I agree. I've heard different feedback though from SIG Network, so it's probably worth talking with them there.
Yeah, maybe we should talk to SIG Network.
Yeah, maybe.
I think that's actually true today, but it may not be true with dual stack forever. And there's some other ideas that they're trying to come up with.
Okay.
All right, cool. So we can kind of take action to talk to SIG Network if we want to work on that at any point. Okay, cool. Let's see. I think that is all I've got. I'll briefly slide back here to this graduation criteria slide, just in case there's any general comments about these graduation criteria, and if we're missing anything, or if I'm totally misrepresenting the status. I think we just kind of resolved this one. Going once.
Do we have a latest discussion on that? On the first point, DNS subdomain?
Not well. Latest was like a year ago.
Okay.
I can dig it up, and then maybe we can talk about that next time, because I don't remember 100%. And yeah, so I can re-ask in this forum here, so, and then like write it down so that we don't, you know,
I believe
forget.
the constraint is coming from MCS. MCS wants it to be a label. I can see why someone might want it to be a subdomain. because often clusters are assigned subdomains. I'm not really sure if there's actually any issue with MCS accepting a subdomain other than, length.
Yeah, I think there's that. And they're definitely, we super went to SIG cluster lifecycle and asked this question, and I feel like they said label, but I
Okay.
don't remember exactly. So that's like another point. But again, that's totally dependent on if they even want to ever use this, I guess. Because back then we were talking about putting in like KK and lots of things being like basically enforced consumers of this, and now it's a lot more opt-in. So that's not as strong. So yeah, let me dig that up
Okay.
and get the details for you, and then we can discuss in this group.
Cool. Yeah, there's no question that a label is usable in more places. So
Yeah,
it seems like a safer place to start, but of course it will mean that you can't use your subdomain as the ID without some,
right. Finagling.
munging. Yeah,
Yeah,
but maybe that's okay.
yeah. Okay, cool. That is my show. Did anything else get added to the agenda? I don't think so. So
It's a great
pass
show.
it back over to you, Jeremy.
Awesome. I think that is it for this week, unless anybody has anything else they want to bring up. All right. Well, thank you all. And thanks a lot, Laura. It was great. Exciting to see this move forward.
Thank you, Ishmeet, for your work. Woo!
Yeah, thank you very much. It's awesome.
Thank you. Thank you so much.
I guess we will see you all in a couple weeks. Thanks, everyone.
Thank you.
Happy Tuesday.
Thank you.
Bye. Happy Tuesday.
Bye.